Okay, so welcome to my session about JDKs. Welcome to the jungle, a safari through the JVM landscape. And it's all about OpenJDK, more or less, right? My name is Gerrit Grunwald. I'm working for AZUL Systems as a senior developer advocate, and I love GeeCON. I hope you love it too. It's one of my favorite conferences. So OpenJDK, I guess all of you heard of that. You should, which is a free and open source implementation of the Java Platform Standard Edition, or shortly Java SE, right? And it comes with a website, which is, can you read it? It's hard to read, I guess, because they have the lights on here. It's openjdk.org. There you can find information about OpenJDK. And just to make that clear, because that happens quite often when I ask people, what distribution do you use? They say, OpenJDK. Well, just to make that clear, OpenJDK is the source code. That's the project. You use a distribution, right? And this is someone who built the stuff. So it's simply wrong to say, I use OpenJDK, just to make that clear. And it comes with the source code available, and it's on GitHub in the meantime. And again, hard to read, github.com openjdk/jdk. There you can find the sources of OpenJDK. And because it's a project, it's not one company, we have contributors that contribute to this project. And you might be surprised how many that are. This is just the companies, and for all the individuals, I just put 1 point, many individuals, because it's a lot. Do we have some OpenJDK contributors here? No? Okay. Well, but you see big companies like Amazon, Alibaba, Red Hat, SAP, of course, Oracle, AZUL, Intel, JetBrains, and so on and so on. And they all contribute to this project, which is a good sign, because it's not a one-man show, right? So that means you are not rely on one company to do that. It's a lot of different companies, big ones, that rely on OpenJDK, and they contribute to OpenJDK, so it's a safe bet if you stay with Java and OpenJDK, because you can be sure that it will stay in the future. And it comes with a roadmap, and probably you remember these days where we had JDK 6, and then it took 4.5 years, and we finally got JDK 7, which took forever, and then again 3 years, and then we had the big thing, which was JDK 8. By the way, who's using still JDK 8 here? Don't be shy. I see you, okay? It's fine, just go for it. And that was the first so-called long-term support version. But that means you have to wait multiple years until you can really test the new JDK, because there was nothing like these things that we have these days. Well, today it looks like this. We have all these different, every 6 months we have a new version. And then you see the pink ones. These are the long-term support versions. And first they started with a 3-year cycle. In the meantime, we have a 2-year cycle, which is even better. So that means now, these days, you can test the new JDK every 6 months, which is much better. And to give you a better understanding about what we are talking about, we have to take a short look into the JVM itself, because this is the heart of it. And it has 3 big systems in there, so which is the class loader subsystem, the JVM memory, and the execution engine. And if we take a look at the class loader subsystem, then again, this is split into 3 different parts. And then we have the JVM memory, which has more than 3 parts. I don't really read all that stuff. Probably you know it, hopefully. And then there's the execution engine, and it has the interpreter, the compiler, profiler, garbage collectors, and then also some JNR stuff in there. So it's quite complex. It's not so easy. And it's an abstract computing machine, the JVM. So if you have the JVM and you download it from some website, wherever, you will find different things like a JDK and like a JRE. So the JDK, and I see I forgot to color the K. It's a Java development kit. And the JRE is the so-called Java runtime environment. And I will come to that in a second. If we take a look at the JRE, the runtime environment, it just contains the Java virtual machine and the class libraries. So this is all you need to run your application. the JDK is a superset of that. It contains the JRE, plus it has the Java C compiler, debugger, and the Java doc inside. And the recommendation, if you run something below JDK 9, is for development use JDK, for production use JRE. The question is why? JRE is smaller. So let's check who's running in production on a JDK. Nobody. That's good. Good sign. If you are above JDK 8, then there's a different thing called JLink. And now I have to ask you, who's using JLink for production? One. Who's using JRE above JDK 9 in production? Because there are some JREs available. So you should use JLink if you have a modularized application, because you can really shrink down the size of the JDK or the JRE in this case, right? So because you just bundle these modules that you need in your application. So if you run above JDK 9 or 8 in this case, 8, so it means 9 and above, then you should use JLink and create your own JVM for production. Well, now we come to the interesting part. And this is the reason for the whole title, distributions. So any guesses how many different distributions we have? You can just shout out. Guess a number. 8. How much? 20. That's a pretty good guess. Because if we separate them in builds of OpenJDK, then these are the builds you can find. Lots of different distributions. And you see things like adopt OpenJDK. Who uses adopt OpenJDK? Okay. You guys know that this is dead, right? It died with 16.02. I mean, if you're still on 8, fine, but there are no updates, just that you know, right? So there's a success of adopt OpenJDK, which is Tamarin. It's not the same, even if they claim it's the same, but it's not. It's a different distribution. Just keep that in mind. Adopt OpenJDK has no TCK compliance. We will come to that in a second. And like I said, we see all these different things. They are all builds of OpenJDK, and that have been 20 different distributions. And I think, does somebody know Tencent Kona? No? Good. So I also didn't know it before I did that. And this is only OpenJDK. Then we have GraalVM. So who's using GraalVM here? 2. In production? 1. Okay. Native image in production. Okay. And even there we have different distributions. You see we have Gluon, GraalVM, we have Community Edition, Enterprise Edition, we have Liberica Native Image Kit, and we have Mandrel, which is from Red Hat. These are builds of GraalVM, which is also open source. So the big question is which one to choose. I try to answer that one, which is hard, because we have to take a look at the differences between all these different distributions. And therefore, I try to make up some points that might be reasons why I make a differentiation between them. So first of all, there's a so-called support term. Then updates might be a point. Compliance, cost, performance, features. And there might also be alternatives to the standard, right? If we take a look at the first point, which is support term, then many people might ask, what is he talking about, support term? I mean, STS, which is short-term support version, and LTS, which is long-term support version. You think this is available from all distributions? You are wrong. So this is how it looks like. And we see they always come in 6 months apart, so JDK 9, then 10, 11, and so on. And these are the short-term support versions. And then you see these pink things. This is the long-term support versions. And they have now 2 years. The cycle between them is now 2 years. It was 3 years. And there was even a midterm support version that was only by AZUL, and it was only for 13 and 15 because we have 3 years in between. So we offered a specific midterm support version for that. Okay. That means short-term support versions or releases are only available for 6 months. If you go to 19, 6 months later, means two updates later. With 20, 19 is obsolete, so there won't be any updates anymore. That means if you go really in production to something like 19, you won't get any security updates in the future. And that means you always have to update to the next version, to the next version, to the next version. So be careful with that. And then I already mentioned, not every distribution offers STS and LTS releases. Some of them only offer LTS. So there are, I think it's DRAGONWELL from Alibaba. They offer only 8, 11, 17, or even Tencent Kona the same, only the LTS ones. So that means if you would like to play around with new stuff, it reduces the number of available distributions where you can do that. So the recommendation here is, in development, you can use whatever you like. In production, please use LTS releases, right? Because if you run into problems, you have to keep in mind that the STS stuff it contains the new features. And if there's something broke with this stuff, then you really have to update every 6 months in production to the next JDK, which again could contain new features with problems, right? So you don't want to go that way. Just stick to the LTS in production. Can I ask if someone is using STS in production here? Something like 18 or 19 or 16? Nobody? This is good. The next thing is updates, because it's also not forgiven that this is for everybody the same. It's not. So we have CPU updates, which means it's critical patch updates. And then we have PSU updates, which is patch set updates. And the difference, it's not pretty clear to everyone, but the CPU only contains fixes for vulnerabilities and critical issues, nothing more. The PSU is a superset of that, and that also contains fixes for non-critical issues, and it also implements new features, and this means it can introduce new issues, right? So you might remember at the Oracle pages, back in the days where we have version 8 as the standard JDK, there was always something like JDK 8.0.252 and 253. And that was exactly the CPU and PSU thing. These days, they don't do it anymore. And but this is where you could see it. And how it works is, let's say we have it 4 times a year. Let's say in January, we have 1701. And on top, you see the PSU, which contains the CPU. And on the bottom is just the CPU. So 1702, we see again. And then the 1702 CPU contains all the fixes and vulnerability fixes from 1701 PSU. That's how it works. So you're always a step behind if you use the CPU. But you have the advantage that you can make sure that it only contains fixes for critical issues. And it doesn't introduce new features. It has the features from the previous version, but this is now with the fixes in there. And this we have 4 times a year. This is how it works. And now the PSU, the patch set updates, they are available for all distributions. So if you, for example, you download Tamarin from Eclipse, then you get the PSU. They don't have a CPU. Just to make that clear, because people don't know that. The only companies that offer CPU releases are these 3. It's AZUL, Bellsoft, and Oracle. Nobody else does that. And usually you don't see it because you have to pay for it, of course. This is service and support. And the recommendation here is, if you run mission-critical stuff in production, you better stay with the CPU releases, because it makes sense. You don't want to introduce new vulnerabilities, especially not these days, just because you use a PSU that comes with new features. Right? So this is just the recommendation that we give to people. In development, you can use whatever you like. Next thing, compliance. Well, compliance is a little bit more complicated because we have TCK. Who knows TCK? Really, just the few. Are you sure? Well, that's frightening. Well, what it is, it was originally developed by Sun Microsystems. It's intellectual property now licensed by Oracle. It has, for example, for JDK 11, more than 120,000 tests. And you can get that stuff. You can get it and take a look at it. It's really amazing because it tests the JDK itself. Everything in the class libraries, every stuff that you use on your daily basis when you code is tested with this. And any binary that is produced has to be tested, has to fulfill all these tests to get the Java SE compatible logo. That sounds like I don't care to maybe some of you, but that makes sure that you can exchange, for example, a distribution with another one. If both of them fulfill the TCK, then you can make sure that it works. And even the TCK alone makes sure that it works at all. Because if it doesn't fulfill this TCK compliance, then it can fail with some stuff that you do in code. Because if the JDK was never tested for that, then it might fail. You have no idea. So then there is the so-called JCK, which is the Java compatibility kit. And this is part of the TCK. This is the actual test, or the tests that are used when they run the TCK test. So it contains tests that are likely to differ across platform implementations. So you see, if you have specific behavior that is different on Windows and on Mac and on Linux, these tests make sure that it works the same on all platforms, and which is important, right? And also stuff that is difficult to port between platforms, this will be tested. Specific hardware, because we have, for example, we have ARM ports, we have ports for different operating system like IBM AIX and stuff like that, or Solaris. And to make sure that it works on all these platforms, this is the JCK. And then the question is, how do you get access to the JCK? In principle, this is available with no charge. So that means you could ask Oracle and say, I would like to get access to the JCK. They might give it to you. You have to meet the terms of the OCTLA, the OpenJDK Community TCK License Agreement. What a great word. And you have to sign the OCA, the Oracle Contributor Agreement. Let's say you do that. I can assure you, if you run the JCK on your own build of JDK, OpenJDK, it will take days on your normal machine to run that tests. It's amazing how long it takes. Because I tried that. I tried to run some of the tests, and after a couple of hours, I just said, okay, it's not for me. And if you think about that, then you might understand why it's somehow companies put that on their website, TCK compliant, because they really have to test all the different operating systems, architectures for hardware, CPUs, and all these kind of things for each package that they create. That means each binary has to run through all these tests, and it takes days to do that. And we have a server farm just doing that every 6 months, running through all these tests just to get this TCK compliance thing. And even if you see that a distribution says, okay, we are compliant to TCK, then it doesn't mean that it's really for your version. So for example, TCK 8 compliance, these are the only distributions that are really compliant to the TCK when it comes to JDK 8, right? So if we take a look at that, and just keep in mind there's DRAGONWELL from Alibaba. So they have TCK for JDK 8. If we go to JDK 9 and above, they don't have. This is because they implement a feature in their JVM, and this feature doesn't run through the TCK test, right? So that means if you use DRAGONWELL 11, for example, then you might run into a problem just because of that, because it won't pass the test, right? So this is stuff, it's not, because the adopt OpenJDK stuff, it wasn't compliant to the TCK. It doesn't mean that it didn't run, right? But the problem here was that Oracle was not really happy about adopt OpenJDK. OpenJDK is a trademark from Oracle. That's the reason why we have Xamarin these days, right? Because they didn't really like it. Yeah, so this is TCK. If you stumble upon that, then you know what it means. It's a lot of work for the distributors to create this compliance, to make it compliant to this standard. And it's a good thing. It's not a bad thing, because you can make sure that if it passes this test, it will run my application. Then there's another one, which is called Aquavit. Who knows Aquavit? I mean, I don't mean the drink Aquavit, so just to make sure. It's Adoptium Quality Assurance, Vitality, and Speed Test Suite. Wow, another great name. And what it is, if the TCK is for the JVM itself and the class libraries, the Aquavit is for make sure that it really is good on application level performance. So they test a lot of stuff on applications, standard applications, use cases to make sure that the JVM really runs well with all these applications with a good speed. And this is the main purpose of that. Like I mentioned here, designed to test real-world utilization patterns. And they have huge, I mean, it's more than 350,000 tests they run. And again, not everybody has that. So it's only these 7 distributions that are compliant to the Aquavit test. And only this one you can find on the Adaptium marketplace. So these are the distributions that pass the test. They have to pass 2, the TCK and the Aquavit, to be on that Adaptium marketplace. So the recommendation here, if you run something, make sure that it is compliant to the TCK in production, because then you can make sure that your application will work. And to be honest, when I started developing, and before I worked for AZUL, I didn't care. I just downloaded something, installed it, run my stuff, all good, right? But now at AZUL, I just learned that we have so many support cases of customers that call us because there are problems in the JVM, and I wasn't aware of that. So there's a good reason why you should choose a TCK compliant JDK. Okay, cost. This is that's an interesting thing, because we have free versions. Who's paying for Java? 1, 2, 3, 4. 4 people. Yeah, that's interesting, right? We are used to get it for free. So why not, right? It's OpenJDK. I can just download it and then use it. Yeah, that's cool. And all these distributions are more or less free to use. So that means most of them. And you can really download it, install it, run it, and it's cool. So I have to poll another stuff. Who's using AWS and CORRETTO? Nobody? Ah, okay, 1, 2. Amazon, Azure and Microsoft? Someone? No? Who's running on Google Cloud? What are you guys doing? Who's running a monolith here? Who hosted his own server in the company? Oh yeah, look, cool. Oh, that's cool. Because if you use something like a cloud service like Azure, then you usually use Microsoft, Amazon, CORRETTO, and so on. On Google, I don't know. I think there's no restriction, is there? No, you can use whatever you like. Okay, but this stuff you can get for free, download, install, use in production with quotes around specific things like GRAALVM Community Edition. You can use. They have some really weird license. So you can use it until a specific date in the future, and then suddenly it jumps to another license and you have to pay. So you have to be careful with this kind of stuff. With the others on this list, they should be free. Then we have paid versions. Paid versions is, we have Azul Platform Prime, which is our premium JVM with additional features. A Platform Core, where you mainly pay for the service and support that we offer. There's IBM SEMERU Certified. This version passes the TCK test. And the interesting part here is IBM SEMERU is based on OpenJ9, which is a different compiler. And usually you can't really run the TCK on that because it's not really OpenJDK, right? It does the same, but it's a different compiler. It was developed from ground up totally from IBM. What they do, they have to pay to get the TCK. Oracle is smart, right? So usually it's free, but you guys would like to have the TCK, you have to pay for it. Then there's GraalVM Enterprise, you have to pay for this, and Oracle JDK. And these are mainly all based on the number of cores that you use, or vCores. But Oracle had a great idea in the beginning of the year. So can I ask who's a Oracle Java SE subscription here? Who has a Java SE subscription? Oh, okay, 1. Because you might be aware that from January this year, they changed how they calculate the cost from number of vCores to number of employees. So in worst case, that means if you have a company with 10,000 people, and it's not only the people in your company, but also third-party people that work for you, and one of these people uses Java SE from Oracle and clicked off the yes, I agree to this license thing, then you pay for 10,000 people. It's so easy to calculate because for them it's easier to look up the number of employees than figuring out how many vCores you use. So you have to be careful with the this applies for GraalVM Enterprise and also for the Oracle JDK. So check your agreement with Oracle if you use that. Is someone using GraalVM Enterprise, by the way? Nobody? Okay. It's interesting because I always ask who's using that, and there's so much hype about GraalVM, but always when I ask people, nobody uses it really. In production, maybe 1, 2 people, but really not a lot. So let's take a look at the next point, which is performance. And I mentioned already that all these distributions are based on OpenJDK, most of them. And so we have some baseline performance, which is all of these distributions are more or less the same performance-wise. So of course, some of the companies might say, oh yeah, but ours is much better. No, because this is all the same source code, except the SEMERU stuff. And GraalVM CE is also a little bit different. So the GraalVM thing's a little bit different. But in general, performance-wise, there's not a big difference between these. So if someone tried to convince you that you should use CORRETTO because much faster, it's not, right? So just to make sure that you know that, to lead you through the jungle, because this is what people really don't get. And also GraalVM, just because today I got an email where someone asked some people about their opinion about GraalVM, and there's some mystery here what they are doing. Oh, they optimize the code and it's much faster. No. GraalVM has just the JVM implementation, and what they did is they did the C2 compiler in the JVM and replaced that by a compiler that is written in Java instead of C++. This is more or less GraalVM Community Edition. And from that point of view, they do this exactly the same that a JVM does. If you run it in JVM mode, if you create a native image, it creates this native image. And if you use GraalVM Community Edition, it's even slower than if you use a JVM, right? So that means if you, for example, use Quarkus and you create a native image from Quarkus, you can expect that it might be 60% slower or 50% slower than the JVM version. Nobody talks about that because it's so small, it starts so fast, but it's so slow, right? And the same goes for Spring Boot. They have Spring Native, same thing, right? So the performance is not the same. If you use GraalVM Enterprise Edition, that's much better in performance, but you have to pay. So just to clarify these mysteries about GraalVM. As I told you, this is more or less all the same, no difference here. So that means you can choose whatever you like if it comes to performance, except you would like to have high performance. So who's using high performance applications here? Something like high-speed trading? Nobody? No? Banking? Sure, okay, one. Because usually there you have this requirement that you really need high-performance JVMs, low latency, stuff like this. Or Java, garbage collection pauses should be as low as possible. So for that, we have to take a look at the JVM again. And I told you we have these 3 parts where we have the execution engine. And if we take a closer look at the execution engine, then there are 2 things we can change, which is the compiler, and we can change the garbage collector. And it's still a JVM. And in principle, this is exactly what GraalVM does. They exchange the compiler. Oh, and by the way, GraalVM also only has the serial garbage collector, and the newest version has the G1. So this is also a reason why it's not the same performance. And we also do that. So we have our own JVM, which is called AZUL Platform Prime, where we exchange the compiler in the JVM and use the compiler that is based on LLVM. And that one is much faster when it comes to compiled code. And we also created our own garbage collector. But of course, you have to pay for that. It's not for free. GraalVM Enterprise, they have the different compiler. They have other features in there. So these are the only 2 that I really can recommend if you have, or if you would like to have high performance or need high performance for your applications. There is SEMERU. I did a couple of tests, and it starts faster. It has a low memory footprint. Performance-wise, I couldn't really see that it's faster than OpenJDK. So this is more or less the same. But with Prime, we can see differences up to 30–40%, depends on the code. And GraalVM Enterprise is the same. It's a little bit slower than the Prime stuff, but still quite good for performance. And there's one thing that people always forget, because if you have a faster JVM, then it can help reduce cloud cost. Because if you can do the same work with less CPU nodes or cores, then you have to spend less money doing the same work, right? So performance can help to reduce cost in the cloud. So can I ask if who's suffering from cloud cost? I mean, you are developers, you're probably not involved, right? Because some people, you probably heard about that cloud cost is the new big thing, because people figured out that even if they just keep the instances running, they have to pay for it. And then they end up with really high bills at the end of the month. So yeah, this is some point where high performance JVMs can help to reduce cost, even if you don't really need high performance, right? So it's another use case. Another difference where we can take a look at is features. Some JVMs come with specific features, and I'm thinking about, for example, JavaFX. Is someone using JavaFX in the audience? 1, 2, 3, yeah, okay. If you use JavaFX and it came with, it was never part of the JDK, but it came bundled with the JDK up to, I think JDK 10 was the last version where it was bundled from Oracle. But till JDK 10, if you just downloaded JDK from Oracle, you get JavaFX with it. And we still do that with AZUL Zulu and Belsoft Liberica. And the interesting thing is that Belsoft Liberica NIC, which is the native image kit, it's the GraalVM version, it also comes with JavaFX. I think it's the only GraalVM version that comes bundled with JavaFX. So if you are in this space, then these are the JVMs you would like to download and use it. Then you don't have to load JavaFX or OpenJFX in addition. Another thing is ARM32. Is someone working in the embedded space with ARM stuff? It's probably not the biggest market, but it's there. And it's mainly automotive. They use a lot of ARM. And because in cars, you usually don't have a lot of space, so they use ARM32 hardware. They don't need 64-bit for controlling little stuff in the car. And for this is also AZUL Zulu and Belsoft Liberica. We both offer ARM32 support. So for some people that's interesting, for others not. The last point is alternatives to the standard. Well, you will find now JVMs that are already mentioned, but they come with some sugar on it, let's say. For example, there's Amazon CORRETTO. We all know that. And we all know the Lambda problem that they had. And they fixed it using Crack and Firecracker, and they call it SnapStart. And this is a specific feature that is only available in CORRETTO to solve especially the serverless problem that they have with Lambdas. Because if you have a Lambda and you have to warm it up for the first time, then it takes some time to warm that up. And then you have to keep it in this hot state to really make it fast the next time. And if you don't do that, then you have to warm it up the next time again. It takes time. And SnapStart solves that problem. And so when we invented Crack, and they saw it last year at Devoxx UK, they developed SnapStart because Lambdas really benefit from this kind of feature. Then there is DRAGONWELL. So does someone use it? Probably not, right? So if I ask that in Asia, then probably everybody say, yay, I use it. We don't. But they come with a lot of features. So for example, first of all, they have a standard and they have extended edition. And then they have JWarmup, which is the reason why they don't have a TCK anymore. And the JWarmup is stuff that Azul developed in the past. And this is the beginning of what we developed. And then they took it and implemented it. And it works kind of, not really. But yeah, that's maybe China, I don't know. Then they have something called Elastic Heap. This is a GC feature where it gives back memory to the operating system, which is nice. And then they have something called WISP2, which is stackful symmetric coroutine at JVM level. I never played around with that, and it's hard to find documentation. and if, then it's in Chinese, and I'm not really good in Chinese, so I didn't really try it. But yeah, they have these features, and you see that there are companies, and they use that for Alibaba Cloud, which is not really used in the Western world, but in China, this is big, and China is a big market. So that's the reason why it's on this list. So they do a lot of stuff to improve on their own cloud, like Amazon does with CORRETTO on their cloud. They do it for Alibaba on Alibaba Cloud. Then there's the other one that's not really well known, is Tencent Kona, which is, I stumbled upon that, found some Chinese website, and I was like, wow, what's that? Because what they do is they're specialized on ARM. And what they implemented, and that's quite interesting, they implemented Kona fibers, and this is in principle Loom, but they did it for JDK 8 and 11. And it is already available since 1.5 years, and it's faster than Loom. So, and you can download and try. It's interesting, and in JDK 8, which is cool, and 11. And what they also did, they developed ZGC, so the Zero Garbage Collector for ARM. So they are mainly in this embedded area, and they are big. So interesting stuff, maybe not for us, but in China, this is really, it's cool. And I played around a little bit with Kona, and they have some really nice features. You also find they have benchmarks where they benchmark Kona fibers versus Loom, and they show you that it's faster than Loom. I mean, they use probably some early versions of Loom, but still, I mean, it's impressive. Oh, then we have GraalVM. I already mentioned that. Community and Enterprise Edition, of course. It's a polyglot VM, so that means it's not really a JVM. It has one part that is similar to JVM. And there they changed the C2 compiler to Java, to one that is written in Java. So I have to say it like that. It's interesting what they did. They wrote the compiler in Java, compiled it to a native image, and then used this one as the compiler for GraalVM. In principle, that's what they do. It's quite interesting. Yeah, it comes with the JIT compiler. That's what I mentioned already. And it also has this AOT compiler that creates the native images, which is the big thing these days, but nobody seems to use it, because every time I ask for it, nobody really used that stuff in production. I mean, I use that on my own for little tools, because you can create one executable, which is great. But in production, I just found a few people that really use it. Then we have IBM SEMERU. SEMERU, I already mentioned that. We have two different editions, community, and then the certified one that has the TCK compliance. And it comes with OpenJ9 or the J9 JVM, which has the faster startup. It has a lower memory consumption. Who's using OpenJ9? Someone here? SEMERU? No? Yeah, it's not that widely used. It's interesting. It also has an AOT compiler, which is in principle similar to the one that was in the JDK. That was removed, and now it's coming back again. So yeah, back and forth. And this is interesting. They have a faster startup to dynamically compiled AOT code. I'm not sure how that works, because AOT code usually is statically compiled. They say it's dynamically compiled. I don't know. I didn't really try, but it helps starting up faster. And then they have instant on. That's the same that we do with Crack. Really exactly the same. They have a different API, but it's more or less the same technology, but they use it on their JVM. It's called Instant 9, and I think Open Liberty makes use of it, Instant on. And they have something called a JIT server. So that means you install the JVM on one server, and then you can use this server to compile the code. Because in the JVM, you have the first interpretation, then you have the C1 compiler, the C2 compiler, and then finally you get the highly optimized code. And if you have a JIT server, then you can just ask the server for the compiled code. So you compile it once, and once it's optimized, then you only get back the directly best code you can get, which saves some time on the local instance, right? But this is only, as far as I know, one instance running, so one server instance. Then we have AZUL Zulu, which is what we do. We have an inbuilt vulnerability detection. So that means who's using security scanning in the IDE, like a plugin, like Sneak Code or something like that? Just a few. Who's using that in CI/CD? That's good. Who's using security scanning in production? 1, 2, 2 people. Okay. Yeah, that's what I thought. And that's why we created this. Because what we do is if you have the JVM, then the JVM loads all the classes, right? So it knows exactly what code is used and even from which library and which version. So that means the information is already in the JVM. We only wrote something that is like, we name it a forwarder. And the JVM calls to the forwarder and says, here's the stuff that I load. And then the forwarder calls a web service and that checks against all the vulnerabilities. And then it can tell you in production, you load this and this classes. You have a dependency on log4j, but you never use it because you don't load it. Right? So we can do that. And then we have crack. I talked about that last year, where we can take snapshots from a running JVM and then restore it from there. Then we have AZUL Platform Prime. This is our other JVM, where we have the specific compiler that I mentioned already. We have a different garbage collector, which is pauseless. And the biggest customer that we have now, let's say the customer with the biggest heap. What do you guess is the biggest heap that we can handle in the JVM? What? Gig. 128 gig. Someone more? Now then, okay, it's 20 terabyte. The heap. The heap. And we can do pauseless garbage collection on that one. I just always have to imagine the machine that is running on, right? But it's 20 terabyte, yeah. And this is the reason why it's only for high performance stuff, because a normal JVM can't handle this amount of memory. Then we have Ready Now, where and this is the stuff that DRAGONWELL copied, which is called JWarmup, but it's not really the same. Because what we do is the compiler is compiling all this stuff and optimizing, and we just store all the optimizations in a specific file. And the next time you start it up, it doesn't do interpretation and all that. It directly takes the code, the optimizations, and applies it to the compiler. It goes directly to the C2 compiler, which is faster, or in this case, to the Falcon compiler. Then we have a cloud-native compiler, which is the same thing that IBM does with this WebJIT server. Just we have a cluster where we have a couple of our compilers running, and then if a microservice just starts up, it calls the compiler with the code, and if the code was already optimized, you directly get back the optimized code. And the vulnerability detection that I already mentioned that runs in production. So that makes this a non-standard version. And of course, we have crack. We always have crack. So, takeaway from that session. Are all those builds of OpenJDK really different? Technically, not really. It's the same. So if someone approaches you and tells you, hey, you have to use this JDK, it's much better, it's faster. No. If it's a build of OpenJDK, it's not faster, this is for sure. It also doesn't really save your memory or stuff like that. I heard these rumors. Oh, if you use whatever distribution, it's more. It's really much less memory than the other one. Oh, that's bullshit. It's not. Right? If it's OpenJDK based, it's more or less the same. If it comes to service, support, and cost, then probably, yes, there is a difference. And if you don't pay for support and service for your JDK, that's fine. But just ask yourself, what if you run into trouble? You can wait 6 months for the next release, or you have a support contract and then you can call a company that will fix it for you, right? So, means choose wisely when you choose your JDK. And with that, thank you for attending. And I think we still have time for questions because it's 5 minutes at least, I think. So if there are any questions, I think there is this app. Oh, I have to check that. I guess I have to show it to you. Right? Oh, there are questions. Oh, yes, I hope I can. Let me, which is it that way? Ah, okay. So the question is, can we use AZUL JDK on dev environment without pay? Yes, Zulu is free. You can download it. And this is also some of these rumors because, oh, you have that paid version. Yeah, we have, but you don't have to pay for it. It's only if you need support. You can use that for production for free and in dev for free. Zulu, not Prime. Right? Prime you can use for testing and evaluation for free. And if you use it in production, you have to pay for it. But if you Zulu, it's free. You can just download and use it in production. And we won't come a year later and tell, oh, now you have to pay. No, you don't have to. The other one is there any website that offers concise summary of what each distribution know. That's this session. There is no website, because the reason for this session is that people from our marketing department approached me and said, you know what, we get so many stupid questions about what is the magic behind GraalVM and all these, why is it fast, it optimizes my code? No, it doesn't. So it's really, people don't know. It's a little bit of a problem. I created an API, which is called Disco API, that gives you access to all the distributions that you saw here, the binaries, you can download it from there. And when I did that, that was the reason why I then said, okay, I can also do this session, because I know most of the distributions out there. There's not really one website where you can find all this info. What are the differences? I created a matrix where I have everything in there, but yeah, I didn't really share it yet. So maybe we will put something out on Fujay, which is also a page you might want to check out, Fujay.io. It's the place, everything about Java, you can check it out there. What is the price for Azul Platform Prime? Good question, I have no idea. I'm not sales, sorry. I really don't know. It's per core and vCore, that's what I know, but I really don't know the price. I'm not even sure if it's on the website. I hope so. If not, ping me on Twitter, and then I will figure that out. Okay. How many bugs are found by clients to use support and oh, yeah, that's an interesting one. So I was surprised when I saw that we have, for each release, probably we have a handful of issues that we have to fix in the JDK. I wasn't aware of that. This is our main business. We do support and service for the JDK. And I didn't know that there was so many customers that really run into problems that are based on the JVM. So what we do, we fix that in OpenJDK and give the customers a specific fix for their problem, and then we backport that, or we contribute it to the OpenJDK project, and then it gets into the main streamline. So how many, I don't know. It always depends, but we have we have a support team of 20 people. They just do support. So, and these people are busy. So yeah. Is Azul JDK use C2 compiler? Yes, Zulu uses the C2 compiler. And the Prime uses the Falcon compiler. So Zulu is a build of OpenJDK, like every other, like CORRETTO. They all use C2, everyone, except Prime, OpenJ9, and GraalVM. Everybody else uses C2. That's the same. Is Crack going to be standardized? Yes. This month, we will come out with a version of Crack in Zulu, because we are not sure if it will become part of OpenJDK. Probably not, because it's not in our hands. So we decided to make it part of Zulu. So if you would like to use Crack, we will offer that from end of April, I think is the plan. And we will go live in May with that. And then we will also offer support for that. So and then you can use that in production, and it's without any cost. Mythical Oracle has functions, so it won't run on Red Hat. That's not true. So Oracle JDK 8 Oracle has some specific parts in their JDK. For example, they have a specific font that is licensed by Oracle. And in all other OpenJDK builds, you don't find that font. With Azul, we have a package that gives you the same font, because we also bought it and we licensed it. And if you need it, we can give it to you. Then it's really the same. This is only if you have desktop apps. The other thing that's different in JDK 8 is WebStart support. Oh, who's using WebStart? Don't be shy. Nobody? Are you sure? Because I know that many people still use it. This is also something that is only available in the Oracle JDK 8. And in the OpenJDK, they have something like ICT Web, I think, was the one that was in there. Not exactly the same. So these are points where people run into problems with when they use OpenJDK versus Oracle JDK. But usually it should be the same, because they build it from the same source. So it shouldn't be a big difference. And I think that's it. Enjoy the conference.